So now on to section 5.1, probability distributions. So what a probability distribution means is you are going to have more than one probability at a time, and we're going to make a table with all the possibilities. Suppose that you flip a coin 3 times. So there's heads and tails, of course. X is going to be the number of heads. So what are the possibilities that X could equal? Well, it could be 0 heads. It could be 1, 2, or 3. So this would be 0 heads, tails, tails, tails. 1 heads, it could be the third coin, the middle coin, or the first coin. So anyway, here's all the possibilities. In grand total, there's 8. So what are the probability for each case? Well, when x equals 0, there's just 1 out of the 8. When x equals 1, that's 3 out of the 8. This one is also 3 out of 8, and then 1 out of 8. And notice if you add these up, these fractions right here, 1 plus 3 will be 4, plus another 3 is 7, plus a 1 is 8 out of 8, which equals 100%. So nobody got left out, nobody was double counted. That is a probability distribution table, or just called probability distribution for short. So discrete random variables are variables that can be counted. So for example, the number of goals that a player makes, the number of chickens that a farmer has, these are things that you can count. Continuous random variables are things that are measured, like the height of a person, the weight, things that you measure, that's going to be continuous. So basically in chapter 5 we're dealing with discrete, and in chapter 6 we'll do continuous variables. And then after that they're going to be mixed together. So with the discrete variables, you'll be able to list what x equals. Like with the last one, x equals 0, 1, 2, and 3. And then the probabilities. And that is how you make the probability distribution table. So is this a probability distribution? Well, at first it looks like it. There's 2 requirements though. One is all of the probabilities have to be between 0 and 1. So this one would be a 0.33, a 0.66, and a 0.33. So yes, they followed that rule. Then the other rule is, if you add up the probabilities, it has to equal exactly 1. And this would be 1/3 plus 2/3 is 3/3, plus another 1/3 is 4/3. And 4/3, that does not equal 1. So this is not a probability distribution. Next up, roll a pair of dice. There they are. A 5 and a 1 means a 6. So what are all the possible outcomes? Well, since the black die has 6 sides and the red die has 6 sides, 6 times 6 will be 36 possible outcomes. And here they are. So it could be that they're both 1. It could be that the black one is a 1 and the red one is a 2, or the black one is a 2 and the red one is a 1. And anyway, these are all the 36 possibilities. This one over here adds up to 12. These two add up to 11, and these two add up to 11. These are the ways that you can get 10, etc. There's all the possibilities. Now let x be the sum. So I was just saying, this would be 12. These add up to 11, these add up to 10, etc. And what's the probability for each one? Well, the grand total is 36, so for this one, it's going to be 1 over 36, and then 2 over 36, etc. So it counts up 1 out of 36, 2 out of 36, until it gets to the 7, which is the most common, that's 6 out of 36, and then it counts back down. Now, make this a table. So here's the probability distribution table. So it starts with 2 when you get a 1 and a 1, and it ends with 12 when you get a 6 and a 6. Now calculate the mean. So when you've got a table like this, the way to calculate the mean is you multiply each x with its probability. So a 2 shows up 1/36 of the time, so multiply those two. A 3 shows up 2/36 of the time, multiply those two. And I just make an extra column with all of those. So multiplying across, that would be 2/36. Multiplying across, that would be 6/36, etc. So with the table, you just multiply straight across and create this new column. Then the formula right here is saying sum those, so add those up. So add up all those fractions, and because they all have the denominator 36, I really just need to add the numerator. 2 plus 6 plus 12 plus 20, etc., all the way till plus 12. And then it's divided by 36. So that one turns out to be a grand total of 252 divided by 36, which is 7. So that is the average, which is good because that's the number that's showing up in the middle. It's also the number that shows up the most. So that's the average. Now, sometimes we use x bar for the mean, and sometimes we use the mu. X bar is if it's just a sample. So if I would have only done 2, 3, and 4, that's just a sample. Since these are all the possibilities when you roll 2 die, that means it's the whole population. So it would actually be the mu equals 7. Next up, how about the standard deviation? So I start fresh. The formula goes like this. So instead of multiplying just x with its probability, you'll need to square this first. So this would be 4 times the fraction 1 over 36, and then 9 times the fraction 2 over 36, etc. Then add those up, subtract the mean, which we just got was 7, so we'll be subtracting 7 squared. Take the square root, and that's how you get the standard deviation. So in order to show the steps, I need a new column where I'm going to put the x squared times the fractions. So here we go. So this would be 4 times 1 over 36, that's 4 over 36. This one would be 9 times 2, so that's 18 over 36. Square this would be 16 times 3 is 48 over 36, etc. So do that all the way down. And then I need to add them up. And it adds up to 1978 divided by 36. So that is what's going to go right here in the formula. So we've got the total is 1978 over 36, and then subtract the mean squared, put that in a calculator, and the standard deviation turns out to be 2.438. So now that we've got the mean and the standard deviation, we could use it. Would it be unusual to roll a 4? Well, since we've got the mean and standard deviation, we'll find the z-score. So that is, take the score, which is what's being asked about the 4, so that goes right here, minus the mean, which is 7, and then the standard deviation, 2.458? Well, anyway, I'll find out in a moment. Oh, 38. So it's the score of 4 minus the mean divided by the standard deviation, and this does not go past a negative 2.0, so it's not unusual. Would it be considered unusual to roll a 4? What? Deja vu, didn't I just say that? I did, but I looked at the homework and they ask you to do it another way as well. And that's use the range rule of thumb. The range rule of thumb is this basic formula right here, that the range is approximately equal, so this should say approximately equal, to 4 times the standard deviation. So let's say that you didn't have time to find the standard deviation, then you could use this as an approximation. So the range means take the biggest score, which is 12, minus the smallest score, which is 2, and you subtract those, 12 minus 2, that's going to be 10. And now solve for s, so divide both sides by 4. And 10 divided by 4 is a 2.5. Now keep in mind, on that previous page, it took me quite a while to square all those numbers and then add up the fractions and then do the formula, and I got a 2.438. Well, here, with just like 2 steps of easy algebra, I was able to get 2.5, which is really close. So this range rule of thumb can be helpful to save you some time if you don't have time to find the standard deviation. Okay, now we're going to use the 2.5. So if you take the mean, which is 7, and add 2 standard deviations, that's going to give you, this will be a 5, so 7 plus 5 is 12. So that's like the top number. Anything beyond that would be considered unusual. Then take the mean and minus 2 standard deviations, so that would be 7 minus 5 is 2. So everything between 2 and 12 would be considered usual. Anything beyond that would be unusual. So the 4 is between those two, so it's not unusual, it's usual. Then sometimes you'll be asked, find the expected value. That's just a fancy way of saying find the mean. Because the mean is the average, so that's what I would expect to happen. Here's an example. This company's invested $80,000 for some new product. And then there's a 20% chance they lose everything. They lose their $80,000. So they made some product, they took it to market, nobody bought it, and they lost all of their investment. There's a 40% chance they break even. In other words, they spent $80,000, but they're going to make $80,000, basically just paying off their bills. And then there's a 40% chance that they make $60,000. So what is the expected amount of profit? So I'll let X be the amount of profit, and then I'm going to make a little table. Since X is profit, it's possible that they lose their $80,000. That's a 20% chance, but I make that as a decimal. It's possible they break even, which means 0 profit. That's a 40% chance. And then they could make a profit of $60,000, and that would be a 40% chance. So then find the mean. So multiply across, and multiply across. So negative 80,000 times the 0.2, 0 times the 0.4, and 60,000 times the 0.4. It's a grand total of $8,000. Which means that if the company does this over and over again, in the long term, they'll make $8,000 on average each time.